Suppose the college is considering a new computerized placement test, which has 40% of all students taking remedial arithmetic. A. If 8 randomly chosen students take the placement test, what is the probability that exactly 2 of them will have to take remedial arithmetic? Well, we need to decide what type of problem we're working with before we can come up with an adequate solution. So first thing, if you'll notice, the given information is just one single probability, but we want to expand that probability out to multiple events. And also, either a person's going to be placed into remedial arithmetic or they're not going to be placed. So there's only 2 outcomes on any given trial. So this is definitely a binomial problem here. Now, for any binomial distribution, there is a binomial table that lists the probability of every single one of your events along with, the probability of every single one of your events for each particular outcome. So you don't really need that distribution for every single one, though. You can look up any individual one through the use of either Binompdf or Binomcdf. So, oops, that's the wrong one. Distributions menu. Now we look for Binompdf and Binomcdf. Here we go. Binompdf will look up one outcome at a time. Binomcdf will look up multiple ones and add the results together. So here we have 8 potential outcomes, and we're looking for the probability exactly 2 of them will take remedial arithmetic. So we're only looking for 1 outcome. So Binompdf is what we want. So I'm going to do Binompdf, and you give it as n, p, and x. So n is your number of trials. So I'm going to give 8 trials. P is the probability of success on any given trial, so 0.4. And x is the number of successes that we wish to occur. So this is going to be, from the calculator, Binompdf 8, 0.4, 2. 0.2090, and just rounding to 4 decimals. Part B, if 8 randomly chosen students take the placement test, what's the probability that at least 5 of them will have to take remedial arithmetic? Well, here, now we want at least 5 events to occur. So we're looking for multiple things to happen, and we want to add up the results. So we're going to use Binomcdf. Now, Binomcdf is going to give us, well, it takes the same inputs. Let's start there. It takes n, it takes p, and it takes x. Now, n is the number of trials. P is the probability of success, so nothing changes there. X is the basically the cutoff where we want to stop summing things together. The thing about this is it will start with 0 successes, find that probability, then go to 1 success, 2, 3, 4, and to 5, and it does 5, but it stops at 5. Then it adds the results together. At least 5 would be 5 or more. So the problem here is what we need to do is we need to stop this counting at 4 and do 1 minus that result. So let me show you a table, so maybe that'll help out. All right, so in this table, I didn't do any of the probabilities. They're just going to come from the calculator anyway. But what I want you to understand is why I'm doing what I'm doing here. So when I input Binomcdf 8, 0.4, 5, here's what comes up. It's the sum starting from 0 and then going all the way up to 5, and it includes 5. So it adds all those probabilities together. The problem here is I want at least 5. That would start with 5 and go higher than that. Now, if I just do 1 minus Binompdf 8, 0.4, 5, then that's going to give me the sum from 6, 7, and 8, because that's going to be the complement of this sum right here. So if I want these to add together, then I need to calculate all the probabilities from 0 up to 4 and then take the complement of that. And that's why I'm doing this function, and then 1 minus that function gives me the complement, which is this sum up here. So without further ado, let's find the probability. So 1 minus Binomcdf 8, 0.4, 4. And there is my answer, which is 0.1737 when we round to 4 decimals. Part C, of 8 randomly chosen students taking the placement test, what is the probability that at most 3 of them will have to take remedial arithmetic? Well, we're going to be using Binomcdf again here because we're going to be adding up individual probabilities, getting the sum of the total. Now, the inputs for Binomcdf, here's what we want to do. So, of course, it takes 3 inputs, n, p, and x. And n is the number of trials. It's still 8. P, probability of success, still 0.4. X is the maximum number of successes that we want to stop the adding with. So if we want at most 3, then we want 0, 1, 2, or 3 events to occur, which is nice because I just put the 3 in here, and that's exactly what Binomcdf is going to calculate for me. So I don't need to do complements or anything, different. Just put those as inputs. 8, 0.4, 3. And we get the answer of 0.5941. Part D. If 726 new students take the placement test, there is a binomial distribution that describes how many will need to take remedial arithmetic. What is the mean of this distribution? Well, in order to find the mean of a binomial distribution, we have a fancy little formula here, which says just take n times p. So in this case, we have 726 students, and our probability of success is still 0.4. So if I take 726 times 0.4, then I get 290.4, and this is really just round off error from the calculator. The calculator here, you won't really see that because it does a little bit better job of like cleaning up your answer. But 290.4 is the answer that you should get. So let me just clean that up. Part E, what is the standard deviation of the distribution in question D? Well, again, for binomial distributions only, we have a nice little formula for getting standard deviations of those. It's just the square root of n times p times q. So if I take the square root, 726 times 0.4 times 0.6, I end up with 13.2. So that's the standard deviation of that distribution.